get radians? R. Remember? How do you get radians? Divide by the radius, right? Divide by R. So once we know A, we know B. Oh, sorry, once we know B, we know C. It's easy. All right. Well, if I'm asking you for tension, what do you got to draw? Force diagrams right away. So this and this. This is T. This is FG. Now, if this is a force diagram, what do I have to draw here? Instead of a force diagram, I have to draw a blank diagram. What it will insert the appropriate term. Force is like what in rotation? Torque. So this is a force diagram, or in college, very often, please notice, this is often called a free body diagram. Okay, so when you see FBD, I don't know, it doesn't mean furry but deadly or whatever. It means free body diagram in college. And now we're going to do a torque diagram. And there is my torque diagram. And this is tension, and that's radius. So if I maintain my color scheme, then I say the sum of the forces is equal to MA. And this is mass of the hook times the acceleration. And I'm going to say mass of the hook times G minus T is equal to MHA. And then, maintaining my color diagram here, or whatever, I say the sum of the torques is equal to I alpha. And so here, there's only one torque, and that is the torque of tension. That equals I alpha. And that torque of tension is caused by tension times the radius. And then what is the moment of inertia of a uniform solid flat disk? Well, do you have to memorize this? No, of course not. It's on page 254 in your book. So I put 1/2 mr squared, right, alpha. So if they want to find tension first, then what we're going to have to do is take this, and we already said that alpha is A over R. So this becomes TR equals 1/2 mr squared A over R. Okay? And then that allows me to cancel this, one of those R's there. This allows me to cancel that R, and I get T is equal to 1/2 MA. Now, they asked for tension first, and I know this looks really tempting just to stick this in here and get A first and then figure out the other two, but whatever. Honestly, if I was you, that's how I would do it. I would just stick this into here, solve for A, and then plug it back in here, get that answer, and go up there. But if we want to be technical about it, okay, fine. We can say this A is 2T over MP. This is mass of the pulley, by the way. Now I plug that in here. So I get MH times G minus T equals MH times 2T over mass of the pulley. And now, solve this for T. And gosh, what do I do? Probably the easiest way. Oh, there is no easy way. This is nasty. I'm just going to get MHG. I'm going to move the T over here. So I'll get MH over MP times 2T plus T. And I'll factor out the T and divide it. So then over there I get MHG all over MH monosodium glutamate. Oops, just kidding. There should be a 2 right there. I think that, wow, what a pain in the butt. You know what? Just take this, stick it in there, get A, and then go backwards. because I mean, like they ask for tension first, but if you take this and plug it in here, you get mHg minus 1/2 MPa equals MHA, and you can solve that for A, and then take that into part B and get your answer, divide it by R to get your answer for C, and then just plug it back into this and get T. That's what I would do. Because this is, but whatever, this works. Oops, I should have recorded that. So again, I get 6.21 newtons here, plug that into A, or into this to get A, which is my 4.15, and then divide that by 0.12, which is the radius, and I get 34.6 meters per second squared, or radians per second.